Good morning, everyone. I'm Enrico, and it's a pleasure to be here representing Team ChefAI at this year's GenHack 4 Hackathon. This week, we tackled an important question. How well do satellite-based climate models capture what's actually happening on the ground, especially when it comes to urban heat? Using ERA5 and NDVI datasets, we explored the differences between satellite observations and real-world measurements from weather stations. We set out to measure the gap between satellite data and ground truth from weather stations. For our study area, we selected the Emilia-Romagna region in Italy, a perfect test case given its dense network of weather stations and significant urban development. When ERA 5 reports 38 degrees Celsius, actual ground temperatures can hit 40 degrees Celsius. The statistics leave no room for doubt. With a p-value of 6.12 times 10 to the negative 281st power and sample sizes exceeding 1.15 million and 48,000 observations, our independent t-test confirms this difference is absolutely significant. The largest temperature errors emerge in areas where NDVI drops below 0.5, which marks dense urban environments with minimal vegetation. Looking at seasonal patterns, we found some interesting variations. During summer months, we're seeing an absolute error around 0.55 degrees Celsius. ERA 5 tends to underestimate temperatures, and the data shows wider variability compared to ground stations. In winter, things tighten up. The absolute error drops to about 0.43 degrees Celsius, with a much narrower distribution. This makes sense. Winter brings fewer temperature extremes, and the urban heat island effect naturally diminishes. We calculated the urban heat island index by doing the difference between each location and the average temperature of surrounding rural areas, defined as pixels with NDVI above 0.5. We treated the temperature readings from ECA meteorological stations as our ground truth. After computing the UHI for both ERA 5 pixels and ECA stations, we measured the discrepancy as the absolute difference between these two values. So what did we discover? Our central hypothesis was that ERA 5's accuracy degrades in urban environments, and the data strongly supports this. As you move along the NDVI gradient from green to gray, from vegetation to concrete, the error between ERA 5 and ground truth grows substantially. Why does this happen? Our hypothesis is that ERA 5's coarse spatial resolution means it averages temperatures across large grid cells. This averaging smooths out the localized heat pockets that ground stations detect in densely built areas. Interestingly, the largest errors appear closest to weather stations where local heat variations are measured with the highest precision. On this slide, you'll see our correlation matrix for all variables analyzed across Emilia-Romagna, along with a plot showing how UHI discrepancy relates to other binned variables. Our key findings point to a systematic pattern. ERA 5 consistently underestimates urban heat because of its limited spatial resolution. The magnitude of error directly correlates with land cover, high error in low vegetation urban zones, high precision in rural areas. For city-level climate monitoring, ground stations remain absolutely essential. Satellite data is valuable, but it cannot replace the precision and local detail that ground-based measurements provide. Thank you, everybody.